That's okay. So I want to solve for x. I'm going to solve, so here's the first question. Solve for x. Log base 27 of 81 equals x. I think we did this one last time, but I'll show you again. So we can rewrite this as 27 to the x equals 81. And then we can rewrite 27 as 3 to the third to the x. 81 is 3 to the fourth. Yeah, we definitely did this one last time. 3 to the 3x equals 3 to the fourth. So those are equal. 3x equals 4, x equals 4/3. So if you're solving a logarithmic equation and you see that the base here and the thing there share a common base, in this case the common base is 3, you're expected to do this kind of work where you actually get a nice, simple answer. We'll see another problem, well, maybe not another logarithmic problem, but some other problems you can't do that. You just have to like leave your answer as a logarithm. Yeah, let's look at the next one. Log base 16 of, what do we got here? X equal to negative 3/4. So again, a lot of these logarithmic questions really depend on our ability to rewrite this as an exponential equation. So I'm going to rewrite this as my base, which is 16 to the power, which is negative 3/4 equals an x. There's kind of two different ways to go here. I personally like to think of it as 16 to the 1/4 to the negative third. Right? I always like to do the root part or the denominator part of the fractional power part first. Because 16 to the 1/4 is 2. And you can just say, it's 2. Or some people like to write that 16 is 2 to the 4th, and then to the 1/4, then to the negative third. 2 to the 4th to the 1/4 is just 2. So 2 to the negative third equals x. And then you get 1 over 2 to the positive third equals x, or 1 over 8 equals x. Do be careful. Right? The negative power doesn't mean you get a negative answer. I've definitely seen too many people here say that incorrectly x is equal to negative 8. Right? X is not equal to negative 8. 2 to the negative third is not negative 8. It's 1 over 8. So remember, negative powers mean reciprocals, not negative answers. Okay. Also, please do feel free to stop me if you have any questions. Let me see, I'm trying to see something here. Yeah, okay, that's fine.
Professor?
Yes.
So on homework there's a question, or question number 6, where the percentage wasn't K or something. And I was wondering if we can go over that one, because I didn't really understand.
Sure, I'm not recalling which problem you're referring to. Let me take a look here. So let me grab homework I. Do you remember which problem it was?
It was problem set 24, and I think it was number 6.
Okay. Sure. So the question here is, a virus is spreading among a bird population at a rate of 5% per month. If there are currently 100 birds afflicted with the virus, how many will be infected in 2 years? Sure. So the idea here is that we have some time and some amount. So, and I'm going to measure time in months. Sorry, I'm reading Jonathan's question there. You could also write it as the 4th root of 1 over 16 to the third power. Yeah, totally. You could also write it that way, Jonathan. So I know that the time equals 0. I have 100 birds that are infected, right? That's what this is. Yeah. So there are currently 100 birds afflicted. So currently, I'm going to say that's the beginning time. And then 1 month later, so it says every month, there's going to be 5%, right? It says, 5% spreading among bird population at a rate of 5% per month. So every month, 5% more birds are going to have the infection. So after 1 month, 5% of 100 is 105. After another month, it gets a little weird because you're going to have a fraction of a bird, but 5% of 105 is 5.25. So you'd have another 5 1/4 bird, which sounds kind of dumb. But after another month, you'd have 110.25 birds. I know sometimes the decimals don't really make sense. That's okay. It's just a model. It's approximate. But then after another month, right? So 5% of that would be 5.5125. So, but you're going to keep getting some fractional part of the bird, and eventually it's going to make up a whole other bird. So here you're going to get 115 point, something that's 7625. And after 4, so on and so forth. So, right. The point here is that, right, so after 4, you're going to get like 121 point something. Right, so the point I'm trying to make is you're not just adding 5 sick birds every month, right? Well, so, and this means that K value isn't just 5%, right? You can't say it is not true that y is equal to 100 e to the 0.05 t. This is not the equation. In fact, we know what the equation actually is. The equation is y equal to 100 times 1.05 to the t. That's not what they want us to do, but that's actually a right answer. But what they're actually trying to get you to do is to do the following. Say, well, I know I've got this model, y equals c e to the kt. Right? This is a model for exponential growth or exponential decay. And the idea here is that we're supposed to assume that this is exponential growth, which I don't think the problem spells out very well, but that's what we're supposed to do. So we know that time 0 we have 100 birds. So that C is 100. And then we're going to use the second piece of information that after 1 month is 105 birds to find the K value. So I'm going to plug in 105 for Y and 1 for T. And that's going to allow me to actually find the K value, which is going to give me, so 105 divided by 100 is equal to e to the k. And then solving for k, I'm going to get the natural log of, I'm going to write 105 over 100 as 1.05. And that's going to equal k. So I can actually write my model as 100 e to the k, which is the natural log of 1.05 times t. And here's the thing. This is totally the same as that. It's just a different way of writing it, right? Because e to the natural log of 1.05 to the t is e to the natural log of 1.05 to the t. But e to the natural log of a thing is just the thing. So that's just 1.05 to the t, which is exactly what you have right there. So there's 2 different ways you can write this that really are the same. But that's the idea. So when someone tells you like something is happening at a certain percentage per month or per amount of time, the idea is that you essentially want to say, well, I know how much I have at the beginning, and I do know that 1 unit of time later, I'm going to have that percentage more. And so I can use those 2 pieces of data to figure out what the C and the K are in the exponential growth model.
Thank you.
You're welcome. Back to the other thing. Okay. So let's look at problem 10 on this review. Problem 10 is log base x of 16 equal to 2/3. Again, just another exercise in rewriting as an exponential. Base is x, power is 2/3 is equal to 16. And then if I'm going to solve this, I'm going to raise both sides to the reciprocal power. So I'm going to say that x to the 2/3 to the 3/2 is equal to 16 to the 3/2. x to the 2/3 to the 3/2 is just x to the 1, which is just x. That's why we picked that power. And then 16 to the 3/2 is, I'm going to write it as 16 to the 1/2 to the 3rd. 16 to the 1/2 is the square root of 16, which is 4. 4 to the 3rd is 64. You could also do, although you shouldn't, you could do 16 cubed to the 1/2, but that's just gross. 16 cubed is like 4,096, I think. And then the square root of 4,096, no, I'm off by like something. Anyway, you shouldn't do it that way. It's not smart. You should do it the easier way. Yeah, I do think we do it. Anyway, now I feel like I'm making a mistake. No, that's not. Okay. So yeah. Oh, I guess it is. Yeah, no. 16 cubed is 4,096, and the square root of 4,096 is 64. But right, that seems like a silly way to do it. Those numbers are too big. What are the exponents you used in the 3rd row? This is x to the 2/3 to the 3/2 equal to 16 to the 3/2. So I used and the reason I chose 3/2 was because I used the reciprocal of 2/3, so that when you do a power to a power, those powers multiply, and 2/3 times 3/2 is just 1. So whenever you're trying to solve for x to a power equal to something, the usual method of doing that is raising both sides to the reciprocal power to make sure that the x side is just x to the 1st, which is just x. Yeah, good question. Okay, let's look at the next one. Log base 3. This pen is trash. Sorry. Log base 3 of 13 minus 7x plus minus log base 3 of x plus 5 equal to 2. Word of warning, I definitely asked a question with logarithms like this on your test, and there's definitely an answer that is extraneous. So make sure after you've solved your logarithmic equation that you check for an extraneous, check to see which one is extraneous. And actually write check, right? It's okay. Well, in fact, we'll see here, I think. So I'm going to solve this. I'm going to get log base 3 of, since it's subtraction, we divide the arguments. So it's log base 3 of 13 minus 7x over x plus 5 equal to 2. And then I'm going to rewrite this as an exponential equation so that 3 squared equals 13 minus 7x over x plus 5. Good. I've used up my red pens. Let's see if this one's any good. So that's 9. And so then here's what I would do. And I definitely saw some people make this mistake on the homework. When you're solving this equation, right, which is 9 equal to 13 minus 7x over x plus 5, you want to multiply both sides by the denominator. Right? So I'm going to multiply both sides by x plus 5. I can do a different color. On the right-hand side, the x plus 5s will cancel. On the left-hand side, we'll distribute. So 9 distributes to each thing. I get 9x plus 9 times 5 is 45 equal to 13 minus 7x. I'm going to add 7x to both sides to get 16x on the left. Right, 9 plus 7. I'm going to subtract 45 to get 13 minus 45 on the right. 13 minus 45 is negative 32. Divide both sides by 16, and I get negative 32 divided by 16, which is negative 2. Now be careful. People often see a negative answer and automatically think it's extraneous. It's not. It's only extraneous if you, you could also cross multiply. That's essentially what we did, Jonathan. It's just that up here, right, we would just multiply by 1. So yeah, you can totally cross multiply. So, right, negative numbers aren't necessarily extraneous. It's if the argument is negative. So 13 minus 7 times negative 2, 7 times negative 2 is negative 14. 13 minus negative 14 is 13 plus 14, which is positive. It's positive 27. And then here, negative 2 plus 5 is 3. Since both of those arguments are positive, we're in the clear. Negative 2 is a perfectly good answer. Just to point out, in this one, if there was another answer, like let's pretend that x equal to 4 was an answer. Well, if I plug in 4 here, 13 minus 7 times 4 is 13 minus 28, which is negative. So 4 here, if it was an answer that we got, would be an extraneous answer, right? It's not a real answer because it makes the argument negative. So the way you check if your answer fits is if it makes the arguments of the logarithms positive, right? We're only allowed to take the logarithm of positive numbers. So if you have an answer and it makes either one of the inside parts of the log negative, it's not a real answer, it's extraneous. If you plug it in and it makes every inside of the logarithm positive, then you're safe. It's an answer. And you always want to check the original expression. You don't want to check anything after you've started simplifying things. So once you get your answer, go back to the very, very beginning of your logarithmic equation and make sure each of the inside parts is positive. If any of them are negative, throw it out. Okay. Let's go to the next one. So let's say that 2 equal to 4 over x plus 1 over x squared. I feel like we haven't really done many equations like this, so it seems interesting that it's in this review, but we can do this one. So the way I would solve this is I would multiply everything by a common denominator, which would be x squared. So I'm going to multiply everything by x squared. So I have 2 times x squared equals 4 over x times x squared plus 1 over x squared times x squared. So I've got 2x squared equal to, that's interesting, you could have done it that way. I'm going to cancel an x here and an x here, so 4x. Cancel an x squared here and an x squared here, so 1. And then I bring everything to the left. So I've got 2x squared minus 4x minus 1 is equal to 0. And then I don't think we've talked about the quadratic formula yet, so we could try factoring it. Does this factor? I don't think it does. Maybe we'd have to use the quadratic formula. So you get x equal to negative b plus or minus the square root of b squared minus 4 times 2 times negative 1 all over 2 times 2. So you get 4 plus or minus the square root of 16 plus 8, which is 24 all over 4. I wouldn't stress this question too much. There's definitely not one like this on the test. This feels like it's kind of in here accidentally. So this is how you would solve this equation, but again, I wouldn't worry too much about it. It's kind of a, yeah. All right. Now let's look at number 13. 10 to the 3x minus 1 equals 7 to the x. So you can use any base you want, but if you've got 10 as one of your bases, it usually makes sense to take the log base 10 of both sides. Just like if you've got e as one of your bases, it makes sense to use the natural log of both sides because it just makes things work out nicer. So I'm going to do the log base 10 of 10 to the 3x minus 1 equal to the log base 10 of 7 to the x. And when it's log base 10, you don't write the base. You can, right? You can totally write base 10 there and base 10 there if you want to, but you don't have to base 10. So I'm going to bring the powers down. That's why we take the log of both sides, so we can get the variables out of the exponent. 3x minus 1 in parentheses times log of 10 equal to x times log of 7. What's log of 10? What's log base 10 of 10?
1.
Yeah, exactly. So this is, and that's why we used log base 10 instead of some other base. So this is just 1. So you've got 3x minus 1 equal to x times log of 7. This you can't simplify. You just need to leave it as is. So then we're going to solve for x. I'm going to bring, although it seems unnecessary, I'm going to bring my x's to the left and my other stuff to the right. So I'm going to subtract x log 7. I'm going to have 3x minus x times log of 7. And I'm going to add 1 to both sides. Oops, which should be equal to plus 1. And then before we can solve for x, we have to factor out an x. So I'm going to factor out an x from the left. I'm left with a 3 minus log of 7. So x times 3 minus log of 7 equals 1. And I'm going to divide by whatever is multiplying x. So that x is equal to 1 over 3 minus log of 7. And that's our answer. And I believe on questions like this on the test, I said I just want an exact answer, meaning leave it like this. This is an exact answer. Don't use a calculator to get a decimal approximation unless you are specifically asked to on the test. And I think there's only 2 questions on the test where I ask you to also find a decimal approximation. All right. See here. Yes, so when you have a 10 as your base for an exponential equation, you should definitely use log instead of natural log. Yeah, I agree. All right, let's look at the next one. Determine the points of intersection of those 2 graphs, y equal to negative 3, or functions. Y equal to negative 3x and y equal to negative x squared plus 10. And to find where 2 graphs intersect, or 2 functions intersect, or 2 equations intersect, you set them equal to each other. So I set that equal to that. And I'm going to bring everything to one side. And I'm usually going to try and choose the side so that the thing with the highest power, in this case x squared, has a positive coefficient. So I'm going to bring everything to the left because that's going to make it so that x squared has a positive coefficient. So I'm going to add x squared to both sides and subtract 10 from both sides. So on the left, I'm going to get x squared minus 3x minus 10. On the right, I'm going to get 0. And then if the person writing the question has been thoughtful, this should simplify nicely. This, or I should say, this should factor nicely. This does factor. It's x minus 5 times x plus 2. So the solutions to this equation are x equal to 5 and x equal to negative 2. But we're not done, because the question didn't say find the x values where these intersect. It said find the points where they intersect. So the points of intersection are the xy coordinates. If x is 5, my point is going to be, well, if x is 5, y is going to be negative 3 times 5, which is negative 15. You could also plug it in here. Negative 5 squared is negative 25, plus 10 is negative 15. And then the other point will be when x is negative 2. If I plug it in here, I get negative 3 times negative 2 is positive 6. If I plug it in here, negative 2 squared plus 10 is negative 4 plus 10, which is positive 6. So it shouldn't matter which one you plug it into. You should get the same y value either way. That's what makes them points of intersection. So these would be the 2 points of intersection. 5, negative 15, and negative 2, 6. Okay. Let's see. What is the question? The question was asking to find the points of intersection of these 2 graphs. So we were trying to find where these 2 things intersect. And so we set them equal to each other. And then found the x values where they're equal, and then the corresponding y values where they're equal. Because that's the whole point. 5, negative 15, and negative 2, 6. Okay, let's look at the next one, which is number 15. Find the dimensions of the largest rectangle that can be inscribed under the line y equals 10 minus 5x. So inscribed under the line y equals 10 minus 5x. This question is not written great. It should really say like, oh, it doesn't. No, it does say it. It says in the first quadrant that can be inscribed under the line y equals 10 minus 5x. So here's what we're dealing with. We've got this line, which we should be able to graph pretty easily. The y-intercept is 10. If you let x equals 0, y is 10. If you let y equals 0, x is 2. So my line looks like that. That point is 0, 10. That point is 2, 0. And we're trying to find the the rectangle inscribed. This is the biggest. The biggest, we mean, has the most area. So I don't know what the dimensions are. I'm going to call this side x, this side y, which means the area is equal to x times y. And this point here, which is on the line, is the point x comma y. So what's our constraint? Well, certainly you could draw a rectangle where that corner point was below the line, but you know you're going to get your biggest rectangle if you go all the way up to the point being on the line. So our constraint is that that point is on the line, which means our constraint is this equation, right? This kind of problem, exactly. The constraint's just kind of given to you right off the bat. There's your constraint, y equals 10 minus 5x. And then we're going to throw that into the equation. So I'm going to rewrite my area equation as x times 10 minus 5x. And I personally like to multiply it out. So my area is going to be 10 times x minus 5x times x, which is going to be a minus 5x squared plus a 10x. It's perfectly fine to write it out of order. I'm just writing it this way so it's really, really clear how I'm going to find my vertex. So to find the vertex, the x-coordinate of the vertex is your negative b over 2a, which is negative 10 over 2 times negative 5, which is negative 10 over negative 10, which is 1. The problem said to find the dimensions. We found x equal to 1. To find y, we're not plugging in 1 here. If you find the y coordinate of the vertex, that would give you 1 times 10 minus 5, which is 5. Although I will point out, in this particular example, the maximal area and the y coordinate happen to be the same. That's a coincidence, but it is true here. So I will write, and it's really because the base is 1, right? So if you want to find y is equal to 10 minus 5 times 1, which is 10 minus 5, which is 5. But if the base is 1 and the height's 5, the area is also 5. So in this case, the dimensions are 1 by 5. The area also happens to be 5. But the answer to the question is that the dimensions are x equal to 1, y equal to 5. So do make sure that when you're answering a question like this, you give the answer that's being asked for. What do you do after if the question asks for area? Well, in this case, and in most cases, if you found the dimensions, you can find the area by just multiplying them together. So here the area would be 1 times 5, which is 5 square units, right? Depending on, like, if it was feet, it would be 5 square feet. But I think for the problem I have for this problem, type of problem I have in the exam, I don't ask you for the area total, I just ask you for the dimensions. see, what's the next problem? I'll do one thing here. Oops. Sorry, one sec. Okay. So let's look at number 16. A rancher wants to build a rectangular enclosure for his animals. Ooh. The fencing material costs $2 per foot, and he only has $200 to spend. What dimension should the enclosure be to maximize the total area? What is the maximum area? Okay, so here they're asking for the dimensions and the area. And again, here's the setup. We want to build a rectangular area region. And the material costs $2 per foot. So I'm going to label, so we know that the cost is, and I apologize, I really have to use the restroom. I thought I was going to make it till 2, but I am not. So I'm gonna pause for a moment. How about you guys work on this problem? So this is the pre-16 midterm 1 review. This is problem 16 if you want to go look at it. But I'll say, so the cost is $2 per foot. We have, I'm going to call this X and this Y, and I'm going to, I have $200. And you guys work on that. I'm going to go use the restroom and I'll be right back. All right, sorry about that. So here's how we set this one up. What are we trying to maximize? Or minimize, right? It's not always maximizing, sometimes it's minimizing. In this case, we are trying to maximize the area, which I might not have said before, but I should have. Wants to build a rectangular enclosure for the animals, wants to maximize the area. So we're trying to maximize area. So again, the area is x times y. And then we have a constraint. The constraint is the cost. And the cost is, well, we know it's $2 per foot. So it's going to be, so again, right? The amount of feet we have is 2x plus 2y feet, but it's $2 times that. So the cost is $2 times 2x plus 2y. Because in this problem, all the sides cost the same amount. And we're going to set that equal to how much money we have to spend. $200. And then we're going to try and solve for x or y. Excuse me. So I would probably divide both sides by 4. Right? You could distribute this out first and say you have 4x plus 4y equals 200. And then divide everything by 4 to get x plus y equals 50. And then solve for y or x, either way. And plug that back into the thing that you're trying to maximize. So I'm going to get area equal to x times 50 minus x. Which is going to be equal to 50x minus x squared, or negative x squared plus 50x. So that my vertex, my x coordinate is going to be negative 50 over 2 times negative 1, which is 25. So then we have to find the other things, right? The problem asks us to find the dimensions and the area. Well, so I know my x dimension is 25 feet. And I know that y is equal to 50 minus x. So my y dimension is also 25, because 50 minus 25 is 25 feet. And then you could either find the area by just multiplying x by y, right? It's 25 feet by 25 feet, multiply together. Or you could plug it into your area equation right here and get the same answer. Because if you plug in x as 25, you get 25 times 50 minus 25, which is 25 times 25. In either case, 25 times 25 is 625. So the area is going to be 625, not 62F, 625 square feet. So that's how we would do that problem. Let's look at the next one. See, we've got 8 minutes left. I'm not going to get through all these, as you might have realized. Let's go to some of the exponential growth and decay problems, because I feel like those are the ones you might want to see the most. Also, I should point out solutions to all these. Well, I should point out, because you couldn't see this before because I'm dumb. And sometimes I miss things, I apologize. But there are solutions to these problems posted, as well as just the problems. So if there's anything we didn't get to today that you have a question about, you're certainly welcome to shoot me an email. But you can also just look at the answers that are on campus, and you can actually look at them now instead of just pretending like you could look at them before. But let's look at number 23. This one says bacteria are growing exponentially. So when you hear the thing, something is growing or decaying exponentially, you should be thinking, oh, I've got y equals c to the kt. There are 150 present initially and 450 present 5 hours later. How long does it take for the population to double? So there's 150 currently at time equals 0. And there are 450 5 hours later. So 5 hours later, there's 450. How long does it take to double? So, and again, if you're asked how long it takes for something to double, yeah, to get the y value, I did plug it into the y equation. Jonathan. I had y equals 50 minus x, and I plugged in x equals 25. Exactly. But I should always be thinking about doubling from the original initial time. So to double, I'm asking how long it takes to get to twice 150, which is 300. So that's my setup. I've got y equals c. I've already written y equals c to the kt. Let's plug in. So here's the thing. If you have the amount at time 0, that is your c value. You can just say c is 150 here. Or you could plug it in and say, well, if I plug in 150 for y, I get c e to the k times 0. But k times 0 is 0, e to the 0 is 1, and c times 1 is c. So you get 150 equal to c. And then we use the other piece of information to solve for k. So I'm going to plug in 450 for y and 5 for t. And then I'm going to solve for k. I'm always going to divide both sides by that coefficient 150 or whatever it is in your problem. So 450 over 150, which is 3, equals e to the 5k. So 3 equals e to the 5k. Take the natural log of both sides. So the natural log of 3 equals the natural log of e to the 5k is just 5k. Divide both sides by 5. So the k equals the natural log of 3 divided by 5. That's what's going to go for our model. So now our model looks like this. Y equals 150 e to the k, which is the natural log of 3 over 5 times t. And then we're going to set that equal to 300 so we can figure out how long it takes for the population to double. So set that equal to 300. And now I'm going to solve for t. So I'm going to divide both sides by 150. I'm going to get e to the natural log of 3 over 5 times t equal to 300 over 150 should be 2, which makes sense since we're doubling. And then I'm going to take the natural log of both sides. The natural log of e to the stuff is just the stuff. So I get the exponent, which is the natural log of 3 divided by 5 times t equals the natural log of the other side, which is the natural log of 2. And then solving for t, I'm going to multiply both sides by 5 and divide both sides by natural log of 3. So I'm going to get t equal to 5 natural log of 2 over the natural log of 3. And for this kind of problem, I did ask for an exact answer, which is that. And then I also did ask for a decimal approximation to the nearest tenth. So putting this into my calculator, I get 5 times natural log of 2 divided by natural log of 3. I get 3.15. So I would round that up to 3.2 hours would be the answer that I would want for a decimal. So that's how we do a problem like that. Let's see. I feel like there's one other one I really wanted to look at. I guess I should look at the circle one here. Sure. So going back to problem 17 on this. Find the center and radius of the following circle. 4x squared plus 4y squared plus 12x minus 20y plus 1 equals 0. So a couple things. First, I want to put the x's and the y's together and the constant term on the other side. So write this as 4x squared plus 12x plus 4y squared minus 20y equal to negative 1. And then we really prefer to have 1x squared and 1y squared. So we're going to divide both sides by that coefficient, which is 4. So dividing both sides by 4, I get x squared plus 3x plus y squared minus 5y equal to negative 1/4. I divided everything by 4. And then I'm going to complete the square. So here, I have x squared plus 3x plus half of 3 squared. So 3 halves squared is 9/4. Right? I'm taking 3 over 2 and squaring it. Plus y squared minus 5y plus I'm going to take negative 5 over 2 and square it and get 25/4. And then I'm going to add those numbers to the other side as well. I feel like the person writing this problem probably meant for something else to happen, but that's okay. Sometimes the things you mean to happen don't happen. I think they meant for this to be positive so that this number would come out nicer. It's all right. So this factors as x plus 3 halves squared, right? That number is the number that ends up right there. This factors as y minus 5 halves squared, because again, right, the minus 5 halves is what comes down there. And then it's equal to negative 1 plus 9 is 8, plus 25 is 33. So the center is the value of x and y that makes each of those things 0. So the center is x is -3/2, y is +5/2. And the radius is just the square root of whatever is over here after you've completed this process. So the radius is the square root of 33/4, which I wouldn't bother trying to simplify. You could simplify it a little bit. It's the square root of 33 over just 2, right? So the square root of 4 is 2. But I would probably not worry so much about that.